Good morning everyone. My name is S. Ravi Krishnan. I am third year student from Department of Electronic Communication Engineering at PSNA College of Engineering and Technology. This internship was organized by Emertxe Information Technology. Today I am going to present my embedded system internship work and the project that I completed during internship. The title of my project is Smart Microwave Oven using PIC Microcontroller. The internship gave me very clear idea about how embedded systems work in real life, how software control hardware, and how small electronic products around us are actually designed. In this presentation, I will slowly explain everything from basics so even a beginner can understand. Start with what embedded systems, what a microcontroller, tools used for programming, and finally I will explain project and show the demo. Next, overview. First, I will give a short introduction to embedded systems and microcontroller because they are foundations of my project. Next, I will explain the software tools used to develop embedded applications, mainly MPLAB, X-IDLE and XE8 compiler. After that, I will explain my project implementation, which is a smart microwave oven. I will explain how the system works, what components are used, how different modes operate. Then I will explain the demo video step by step. Finally, I will conclude my presentation with the learning outcomes and thank you notes. Next, introduction to C programming. C is procedural programming language, which means programs are written as a sequence of step-by-step instruction. It is one of the most widely used languages, mainly in embedded systems development. C provides low-level access to hardware, allowing programmer to directly control memory, registers and peripherals. Because of this, it is commonly used in programming microcontroller embedded devices. Another important features of C is efficient and fast executions. Program written in C consume less memory and run faster compared to many high-level languages. C also support modular programming through function, which helps in organizing code, improving readability and reusing logic. Due to all features, C is ideal for microcontroller based applications such as home automation, medical device and industrial control systems. Next is about arrays, pointers, function and string. Arrays are used to store multiple values of the same data type, such as sensor reading or data samples. Pointer store memory address and allow the efficient memory access. They are mainly important in embedded systems where memory management is critical. Function help divide a program into smaller reusable modules. This makes the program easier to debug, maintain and scale. Strings are used to handle text data such as message displayed on LCD or data sent through serial communications. Overall, these concepts are fundamental for memory efficient and modular programming in C. Next is about arrays, pointers, function and string. Arrays are used to store multiple values of the same data type, such as sensor reading or data samples. Pointer store memory address and allow the efficient memory access. They are mainly important in embedded systems where memory management is critical. Function help divide a program into smaller reusable modules. This makes the program easier to debug, maintain and scale. Strings are used to handle text data such as message displayed on LCD or data sent through serial communications. Overall, these concepts are fundamental for memory efficient and modular programming in C. Next, introduction to embedded systems and microcontroller. Now I will explain what an embedded system. An embedded system is a system that is designed to perform only one specific task. It is not like a laptop or computer which can do any task. Examples of embedded systems: microwave oven, washing machine, digital watch, air conditioner, traffic signals. Each of these systems is designed to do one fixed function and it keeps doing that task continuously. An embedded system mainly has two parts: hardware and software. Hardware include microcontroller, input device like switches and keypad, output devices like LCD, buzzer and motor. The software is written in embedded C and it controls how the hardware behaves. Most embedded systems work in real time. This means the system must respond immediately. For example, when we press the start button in a microwave oven, the system should start instantly. If there is delay, the system becomes unsafe. That is why the embedded systems are very important in daily life. Next, microcontroller. Microcontroller is the heart of an embedded system. In single chip that contains CPU, program memory, data memory, input and output ports, timer and interrupts. Everything inside one chip. Because of these, microcontroller are small in size, low power consuming, low cost. This makes the perfect for embedded applications. In my project I used to PIC 16F877A microcontroller. This microcontroller is very popular for learning embedded systems. Multiple input output port, the timer, interrupt support and easy programming. And the microcontroller continuously runs a program and check input like keypad and control output like LCD and buzzer. In simple word, microcontroller acts like the brain and the program is its thinking process. Next, MP Lab X IDLE and XE8 compiler. The main tools are MP Lab X IDLE and XE8 compiler. MP Lab X IDLE is an integrated development environment provided by Microchip. It is used to write the embedded C code, create the project, and compile the programs and debug the errors. In MP Lab X IDLE, I created a new project and selected the PIC 16F877A as the target microcontroller. The IDLE helps us organize the code properly using source file and header files. This is very useful in large project. Even where there is an error in the code, MPX IDLE shows error message and line numbers. This help in easy debugging. Now coming to XE8 compiler. The XE8 compiler is used for 8-bit PIC microcontroller. It converts the embedded C code into X file. The X file contains machine level instruction that the microcontroller can understand. After the completion, these files is used for programming the microcontroller or running the simulations. In my project, I used PICSIM lab to simulate the system. These tools help me complete my project smoothly. Next, project implementation. Now I will explain the implementation of my project. The title of my project is Smart Microwave Oven. The aim of this project is to simulate the working of a microwave oven using a microcontroller. The components used in this project: PIC 16F877A microcontroller, matrix keypad, 16x2 LCD, buzzer, timer with interrupt. System working. When the system is powered on, The LCD shows a welcome message. After that, the main menu is displayed. The menu has 4 options: micro, grill, convention, start, quick start. The user select the mode using the keypad. The micro mode. User enter the cooking time. The timer start and remaining time is displayed. The timer interrupt are used to reduce the time accurately. Grill mode. Grill mode works similar to micro mode. The user sends the time and the system runs until the time is completed. The conventional mode. In conventional mode, the preheating is simulated. User enters the cooking time. System runs accordingly. Quick start mode starts immediately. Uses default time useful for fast heating. When the time reaches the 0, the operation stop. Buzzer turn on. LCD show completion message. This makes the system user friendly. Next, now I will demonstrate the working of my project. First, I power on the system. The LCD display the welcome message which show that the system is initialized correctly. Now the main menu is displayed. I press key 1 to select the micro mode. The LCD asks for cooking time. I enter the time using the keypad. The timer starts counting down. The remaining time is shown on the LCD. When the time reaches 0, the buzzer turns on. Now I return to the main menu. I press key 2 to select the grill mode. I enter the time and start the operation. The countdown works correctly. Next I select the conventional mode. The LCD shows the preheating. After that I enter the cooking time. The system completes the operation successfully. Finally, I select the quick start mode. The system starts immediately, stop after the default time. The selected mode is displayed on the LCD, confirming the user choice. The user then set the cooking time using the keypad. After setting the time, the start and resume button is pressed to begin the operation. Once started, pick microcontroller, activate the output pins which drive relay circuits and indicators. Indicator presenting the microwave or grill operation. The timer countdown is shown continuously on the LCD with the time minutes and seconds. During operation, microwave or grill is considered on through the relay controller. The status LED glow indicating active operations. The stop or pause function is selected. The pick temporarily halt the operations. Update the LCD. The pick microcontroller continuously monitor the timer internally. Once present cooking time reaches 0, the PIC runs off all relays. Microwave grill operation stop automatically. The buzzer indications alert the user that cooking is correct. The LCD then return to the initial standby screen. At last conclusion, this bring me to end my presentation. Through this internship, I gained strong practical knowledge in embedded C programming, microcontroller fundamentals, as well as timer, interrupt, and real-time system design. This concept helped me understand how software closely interact with the hardware in embedded systems. Working on this project have me valuable exposure to how real embedded products are designed and developed from concept to implementation. I would like to sincerely thank Emertxe Information Technology for providing me with this excellent learning opportunity and industry-oriented training.